Now, in the previous video, we talked about two ways to address the two big limitations in LLMs, which is using a technique called RAG or Retrieval Augmented Generation, and using tool APIs for the LLM to perform actions. Let's go through each one of them, okay? So the first one to really introduce RAG is the following scenario. The user's question is, how big is the sun? That goes to the LLM, and then it comes up with the answer. And it does a pretty good job of that. So it's great at producing answers to texts that are common, right? So obviously there is somewhere online that says how big the sun is, so it's really able to quickly answer that question without having um, any sort of not being able to trust it or anything like that. So that's great. But again, we've talked about how they don't have knowledge on your private data and they don't have knowledge on recent data. So if you want to ask something like, how much does Bob Doe pay in rent? You're a real estate management company, you own a lot of properties, and you want to create a system or an LLM that is able to answer questions for you. Well, Bob Doe's rent is not publicly available information, so it will not be able to answer that. Okay? Instead, what you can do is you can instruct or you can manually extract the content from his tenancy agreement or from their contract file, put that into the LLM, put that into the prompt itself, and then if you do that, it is able to answer the question for you. Bob's tenant agreement, Bob shall pay $1,800 in rent. User's question, how much does Bob pay in rent? So that's what you put into the LLM instead. You don't just say, how much does Bob Doe pay in rent? You basically give the LLM the full tenant agreement, and then you ask, how much does Bob Doe pay in rent? And then it answers the question well, and it works really well too. But what if your data store is large? What if your set of knowledge bases is too large to fit into a large language model? You don't just have Bob Doe's contract, you have millions of other contracts. Okay? Well, that's a great question. So this is the process that you might want to follow instead. The user's question is, how much does Bob Doe pay in rent? So what you do first is you have a process that searches for Bob Doe's specific contract in a sea of millions of other contracts. And then you get his contract text, and then you do the same thing you did before. You pass it to the LLM comes up with the answer. So the difference here is that if you only have Bob Doe's contract, it makes it very simple. But if you have millions of contracts, you need a process by which you find Bob's contract first, and you use that to pass to the LLM. Then your next natural question might be, okay, but how do I make sure I'm able to search for Bob's contract? Well, you use something called an indexer, okay? So what you do is you take all the contracts that you have in your database and you vectorize it. You basically create a embedding representation of each of those contracts, okay? After you've done that, then before you pass it to the LLM, you do a comparison between the embedding of the user's question to the embedding of the actual set of contracts to find the most relevant contracts to answer that question. Now, this is moving beyond the scope of this course, but really very simplified. An embedding is, think of it as a translation. Think of it as a different language that machines can understand. So the idea here is you take all the different contracts, you convert it into that different language, and then because it's in that different language that machines can understand, it is very quickly able to find the most relevant contract based on the user's question. And because of that, it's able to what we call search through and retrieve very efficiently the relevant contracts because it's already been indexed, because we've already gone through it and converted it into a format that can be easily retrieved. Okay? So that's basically the process of RAG here. All right. So now this process turns into, how much does Bob Doe pay in rent? Well, what we do is we have an index. We basically think of an index like a book, or think of it as a way for a machine to retrieve the relevant files very quickly. We have an index that has all the contract data chunked and vectorized. We then find the matching results to the user's question. In this case, we find Bob Doe's contract, and then we pass that to the LLM, and then we get our answer. Okay? So in essence, that process of taking a knowledge base, putting it into separate chunks. In this case, we use contracts, but just replace the word contract with chunks. Vectorizing it or translating it into embeddings, which is the process of taking that text and translating it into a process that machines can understand and quickly retrieve. That whole process is called RAG. All right. The idea being, if your content has been indexed, then at the time that the LLM is called, it then finds the relevant passage or chunk of text to your question, takes that out of your knowledge base, and puts that into the LLM's context window. And now the LLM doesn't have to search through hundreds of contracts, doesn't have to rely on its training data. Instead, it has what we've defined as most relevant content for it to answer its question. Now, I could create a whole nother lecture on RAG. RAG is an amazing technique. It's something that's been developed. It's something that honestly advances every single month. Because then you think about, okay, what is the best way to search and retrieve? What is the best chunking algorithm? What is the best way to index and embed and vectorized? Do you need an ETL process before creating the chunks to take your input files like PowerPoint files and email messages and put them into a chunked format? So how do you ETL that? There's a whole science behind it, but this is a very simplified way to do it, because when we do it in the platform that we're learning, it does all of that for you, but it's still good to understand in the background how that's working. Okay, so that is solving one of the issues, which is knowledge. How do you solve the other issue? Very easy. You use APIs. The other issue is that LLMs can only generate text. But now, because we have APIs, which are basically connections to other applications, LLMs can generate the API input and then execute those APIs, which means they can perform actions. So there are APIs everywhere in the software world. The software that you're currently using probably has an API. Your email has an API. The idea behind an API is a systemized protocol for you to transact with the application. Your email has an API to send emails, to list emails, to read emails, all of that. So if you don't want to use the Gmail application, you can build your own application and leverage those APIs to do those transactions instead of having you do them manually. All right. So how this would work here is your user's question or request is to send an email to Bob. Okay. Now the LLM has understanding on how the Gmail API works. It knows how to log in on your behalf using that API, and it knows what inputs it needs to use the send email action. So it's thinking. It thinks I need to send an email. I have access to it using the Gmail API. I'm going to connect to it, pass in the relevant input arguments, and then execute the request. Okay? So it calls the API with the required inputs, which then actually send the email to Bob, and then the LLM just outputs email to Bob has been sent. So this is actually relatively simple. There's been lots of research on how to make this process easier. There's a whole nother field or a whole nother components called MCPs, or Model Context Protocols, which kind of standardize this. But it's very simple. The idea here is you're not using LLMs to generate text. You're using LLMs to generate API input and connections, which are then executed. So it looks like the LLMs are performing actions.